Your AI agent is an amnesiac, and that's a problem. Every time you start a new session, the LLM forgets who you are. It forgets what you want. This statelessness is the single biggest wall blocking AW autonomous agents from being actually useful. 10 DB agent memory kills this. It turns fleeting chat logs into persistent structured database assets. It doesn't just dump text into a vector store. It uses a hybrid architecture on Postgres with the PG vector extension. The system splits data into two layers: raw message logs for detail and summarized reflections for high-level context. This means the agent doesn't have to reread 10,000 tokens of history to remember your favorite coding style. It just retrieves a summary. This architecture drops input tokens by up to 90%. Retrieval latencies hit under 20 milliseconds. You get a long-term memory that feels human, not mechanical. But there's a trade-off. A full database creates operational overhead for small prototypes. Worse, the summarization process can hallucinate details. It can lose the subtle nuance of a raw transcript. Still, it moves the needle from simple chatbots to agents with genuine continuity. Memory is only half the battle. An agent with a memory but no eyes is just a very smart blind person. Most AI agents are trapped in a text box. Meanwhile, the real world runs on clicks, forms, and dynamic JavaScript. Agent Reach fixes this. It maps the document object model into a format LLMs can actually control. It uses Playwright to run headless Chrome instances. It doesn't just scrape text, it identifies buttons, inputs, and navigation elements, then assigns them unique IDs. This turns the entire internet into a promptable API. You can book a flight or fill a complex SaaS form without a single line of custom integration code to keep token costs from exploding. Agent Reach strips out invisible elements and scripts. This reduces HTML input size by roughly 80%. It's a direct threat to the proprietary API economy. Why pay for a restricted API when an agent can just use the UI like a human? Of course, the web fights back. Heavy JavaScript and obfuscated CSS classes can confuse the parser. Companies will deploy aggressive captchas to block this. But the shift is clear. The UI is the NO API. Once an agent can see and click, the walled gardens of the web vanish. Now, let's talk about the most complex environment of all, your codebase. Your repo is a ticking time bomb of technical debt. Grep and fuzzy search are useless when you need to understand how a change in the auth module breaks the payment gateway. Vector search, which powers tools like QHPilot, only finds code that looks similar. It doesn't understand how code actually works. Graphify changes the game. It turns your entire codebase into a queryable knowledge graph. It uses high context models like Cloud 3.5 Sonnet to parse files and extract entities. It identifies classes, functions, and variables, then maps their dependencies in a Neo4j database. This isn't just text matching, it's structural understanding. You can trace the exact execution path from an API endpoint to a database transaction. Onboarding a new engineer drops from weeks to days. They can query the architecture instead of reading random files. You can see the exact blast radius of a refactor before you commit a single line. It's not free though. Running LLMs over every file in a massive monorepo is slow and expensive. You also risk the LLM hallucinating a dependency that doesn't exist. But the trade-off is a deterministic map of your system. We're seeing a fundamental shift in the agent stack. We're moving from stateless prompts to persistent memory, from text boxes to browser control, from vector similarity to structural graphs. This is how we get agents that actually work. If you found this useful, subscribe for more deep dives.